Okay, so let's solve for this number 2. Set work or set B. A 4-pole lap condition shunt generator has a useful flux of 0.07 Weber. So the armature winding consists of 220 turns, each of 0.004 ohms resistance. Calculate the terminal voltage when running at 900 rpm and if the armature current is 50 ampere. Okay, so first things first, as I have said, is to draw the circuit diagram. So this is our positive, negative EG, which is unknown, and then of course our RA, and then our RSH, because this is a shunt generator, and of course our terminal voltage, which is our VT, positive, negative VT. Now, it was mentioned that the current in the armature is already given, which is, it is given as IA, which is equal to 50 ampere. Now the question is about our terminal voltage. Now from here, we all know that we have our terminal voltage, positive, negative VA and positive, negative VSH. Now from here, you would notice that VSH is in parallel with VT. So therefore, if you would take KVL at this mesh 2, we would notice that VSH is just equal to VT. Now from here, in order to solve for our VSH then, so solving for VSH, the next thing to do is of course to take KVL at our mesh 1, right, in which we'll have negative EG plus VA plus VSH equals 0. So therefore VSH is equal to EG minus VA. Now in the problem, we can immediately solve for our EG and for our VA. Why? Because our EG is just equal to our P zone all over 60A. Okay, so from here we have our P, which is equal to 4 pole. Next, our Z, which is equal to, right, there are no conductors given, but there are 220 turns. Okay, so armature winding. Take note that we have 2 conductors per turn. Always. Okay, because if you turn this winding, there will always be 2 coil sides that would be this armature winding will turn to. Okay, so let's see if I have these 2, okay, always 2. Okay, so there will always be 2 conductor involved or 2 coil sides, so it will always be 2 conductors per turn. So from here, since I have Z, which is equal to 220 turns multiplied by 2 conductors per turn, so therefore there are 440 conductors. Okay, so as I have said, if I am discussing something or lectures, okay, always take note of these small things like these 2 conductors per turn, right? So from here, there are 440 conductors multiplied by 0.07 Weber, and of course the speed is at 900 rpm, divided by 60 A, which is equal to our MP. So we have 4 multiplied by M, so there is no plex, so 1. So from here, I may solve for my EG, which is equal to 4 multiplied by 440 multiplied by 0.07 multiplied by 900 divided by 60 multiplied by 4. Okay, so we have a voltage equal to 470 62 volts. That is for our AG. Okay. Now, next thing is our VA. Now, how will solve for our VA? Of course, our VA is equal to my IA multiplied by RA. I is already given, which is equal to 50 ampere, and our RA is unknown. So our RA, so according to the problem, the armature winding consists of 220 turns, each of 0.04 resistance. Now, if we are talking about this turn and the resistance itself is unknown, so therefore we may come to think of it, or we may come to the idea of our current path. Now, the windings are connected in a way that it is connected to the commutator, wherein it would harness the energy that is produced in the commutator, right? Now, or the or vice versa, I should say, or the commutator will harness the energy that is produced within the armature, right? So from this, the next thing to consider is our current path, right? If there are only, if it is connected in a wound winding, so therefore the connection of the turns of the armature resistance is only 2. Why? Because that is what wave, right? 2m. But for our lap is that we would consider the connection of the parallel paths based on how many poles and how many plex is the uh, the generator is, or the armature resistance are wind. Okay, so from this is a lap wound. So what is our current path? A is equal to MP, right? Since M is equal to 1 and P is equal to 4, so it's safe to consider that there are 4 current path. So we would arrange the resistance per current path into 4 parallel resistance, in which this is the current path of the windings in our armature. Okay, so this will be our current from our IA going to our load. Okay, so kumbaga this IA will be like this, considering that this is for pole, okay, or the current path of this one. So in the problems that are given to you in the previous example, that is already our RA total that came from this total resistance of the parallel path. Now from here we have 220 turns, so each of 0.04 ohm resistance. Now considering this one, the next thing to do is of course to multiply this by our resistance per turn. So therefore RA per turn is equal to 220 multiplied by 0.04. This will be equal to 220 multiplied by 0.004, which is equal to 0.88 ohm. Now this is the total resistance of the coil used in the number of turns, in the 220 turns in the DC shunt generator. Okay, this is total resistance of the coil that is not yet connected in parallel. Now since we would divide, or we would distribute all this resistance into this 4 parallel path, so therefore I may say that RAH, in which the RAH will be here, okay, okay, in this diagram. So we divide it by 4 because the 0.88 is the total resistance used in the winding of the armature conductors. Okay, so from here we have 0.88 divided by 4, okay, which have 0.22 ohm. Now upon knowing the resistance of each of the turn or the parallel path, the next thing to do is that we would connect it, okay, with respect of what type of connection it would be used. So if it is a lap winding or a wave winding. So if it is a lap winding, so therefore the wave winding, I should say, you would rearrange this total resistance into only two current path, right, which is equal to 0.44 each. But since this is connected in a lap winding, so therefore we would consider the formula for our current path, which is equal to MP. So therefore there are 4 current path in which each resistance of each armature conductor is equal to 0.22 ohm. Now from that, you would notice that if we would consider the 0.22 ohm resistance, you would notice that they are all connected in parallel, and the connection or the connection of these 4 that would be simplified into RA will be the RA total. Now considering RA total, so RA total will be equal to the parallel combination of 0.22 in parallel with 0.22 in parallel with 0.22 in parallel with 0.22, which is equal to 0.22 raised to negative 1 plus 0.22 raised to negative 1 plus 0.22 raised to negative 1 plus 0.22 raised to negative 1, which is equal to 1 all over 0.22 raised to negative 1 plus 0.22 raised to negative 1 plus 0.22 raised to negative 1. 1, 2, 3 plus 0.22 raised to negative 1. So from here, you would have a value of the resistance RA, which is equal to 0.055 ohm. Okay, so if we already have our RA total, you would just substitute this to this equation. You would notice that our VA, which is equal to our IA multiplied by RA, which is given, our I is already given, into 50 ampere multiplied by 0.055 ohms. So therefore we'll have a value equal to 50 multiplied by 0.055, right? So therefore from this you would notice that the voltage drop in the armature is equal to 2.75 volts. Now upon solving for this, the next thing to do is to substitute all the values. Okay, so therefore our VSH will be equal to 462 minus 2.75 volts. So therefore we'll have 462 minus 2.75. So we'll have a value equal to 459.25 volts. So that would be your VSH. Okay.